All right, today is part 2 of your 8.2 lesson. We're going to cover today examples 4 and 5. In example 4, we're dealing with what two kinds of lines? Horizontal and vertical lines. Now, one of them is a function, the other one is not. Okay, so we're not going to spend too much time on the variables because I think that just maybe gets a little confusing. So I want to go straight into these two. Essentially, they're equations, right? Because they're separated by an equal sign. One of them gives me y equals 3. The other one is x equals negative 2. So I'm going to show you how you would graph this on your graph. Okay, so my first equation was y equals 3. So in this case, there's really nothing to substitute because I don't even have an x value. All I have is a y value. So when that happens, I'm going to plot my point on the y value that it gives me. Since it said y equals 3, I plot my point on the 3, and I'm just going to draw a horizontal line through the 3. And then I'm going to label my equation y equals 3. And I'm done. That's how I would graph one of these when I just have the y value. You do have at least one of these on your homework tonight, so that's how you would do it. Now, what if it gave you an x value, like x equals negative 2? X equals negative 2. Where do you think you would plot your point then? Very good. On x equals negative 2. So x equals negative 2, you're going to draw your line straight through. Now, we're doing it on the same graph on our notes, but you do need to have each question on separate graphs in your homework. And then you would say x equals negative 2. Now, the last thing we need to talk about is one of these lines is a function and the other one is not. Now, one of these lines, or one of these, I should call it equation, one of these equations would pass the vertical line test. The other one would fail it miserably because it is a vertical line, right? So a horizontal line is a function. So when it asks you on your homework tonight, graph the equation and tell whether it's a function, the answer is yes if it's horizontal. What's your answer if it's vertical? No, it's not. It fails the vertical line test, so it's not a function. Vertical lines are not functions. Their slope is undefined. All right, so that's it for example 4. Now, in example 5, it's basically just like example 3, except I just have one more step that I have to do at the very beginning. And that is to write my equation in function form. You do not have to write down this definition, but this is what it means. Function form has y by itself on one side of the equation. And then my x value always comes first, and then my number that stands alone. In 8.3, we're actually going to define this a little bit more in depth, but for now, you just need to know that function form is y by itself on the front part of the equation, then your x value, then your number that stands alone. Got it? So, let's look at a couple that are not in function form. Okay, so I have x plus 2y equals 6. Now, what's my goal? My goal here is to get y by itself on one side of the equation. So the first thing I'm going to do is I'm going to move the term that is not connected to my y. How would I move x to the other side? Just subtract it. I mean, if it was 2x, you would subtract 2x, but it's just x, so you subtract x from both sides. But 6 minus x, those aren't like terms, right? But which term did I say comes first? Your x value comes first. So now I have 2y equals negative x plus 6. But I'm not done yet because y still is not by itself. What do I need to do now? Divide everything by 2. Divide this by 2, divide negative x by 2, divide 6 by 2. And now I have my function form. y equals negative 1/2 x plus 3. Might be a little hard to read on the green, but y equals negative 1/2 x plus 3. I'll make this maybe a little darker. No, that's not really helping. All right, actually, let's go ahead and do our input-output table. So now that I have the equation in function form, all right, now my equation written in function form is y equals negative 1/2 x plus 3, right? So now I'm going to do my input-output table, which you've already done in example 3. Right? Yes? Yes. Okay. So I have my x and my y. But now here's the catch. Since I have a fraction connected to my x, I want to use x values that are multiples of 2, so my fraction will cancel out. Okay, you see that there's a fraction there? So my multiples of 2, what can I use? What are some small? Negative 4, negative 2, 0, 2, and 4. Negative 4, negative 2, 0, 2, and 4. Now, if it's a whole number, what's my domain that I use? What's my standard domain that I told you guys? Negative 2, negative 1, 0, 1, and 2. That's the one that you use 9 times out of 10. The only time that you're going to use different x values is when you've got a fraction here and you need to get that denominator to cancel out. All right? So if I multiply by something that's not a multiple of 2, then I'm going to end up with a fraction. I have to add and subtract, and then I have to find a common denominator, and it's a mess. Okay? So now, when I plug in a negative 4, what do I get? I get a negative 2 plus 3, which is positive 1. Okay? Go ahead and fill in the rest of your chart. All right, so let's fill in the rest. Okay, we made that mistake because this should be 5 because double negative cancels to a positive. And then you're going to have 1 plus 3, which is 4. Then you're going to have 0 plus 3, which is 3. Then negative 1 plus 3, which is 2. So we're just decreasing by 1. And now what do you think you're going to do with those numbers? Pair them up and graph them. Okay, which we just reviewed, but just for review's sake, let's do it one more time. You don't have to do this on your notes. I'm just going to show you. All right, so what's your first ordered pair?
Negative 4 and 5.
Negative 4 up 5. And you plot it. What's my next ordered pair?
Negative 2, 4.
Negative 2 up 4. What's my next one? 0, 3. What's my next one? 2, 2. What's my next one? 4, 1. And looky there, it's a straight line. Draw my line straight through. And then what's the last thing I do? Write my equation, negative 1/2 x plus 3, and I'm done. All right, so on your homework tonight, you have 4 like this, okay, where the first thing you're going to do is you're going to write it in function form, y equals, and then your x value plus your number, okay? Then you're going to do your input-output table. What's the domain that I want you to use on your input-output table normally? Negative 2, negative 1, 0, 1, and 2. What about if you have a fraction, though? Use multiples of the denominator so your fraction will cancel out. So let's take this one for example. Okay, we'll do this and then we'll be done. I want you to go ahead and rewrite this equation in function form. Rewrite this equation in function form, please. All right, so we've got 3x plus 6y equals 12. Well, first thing I need to do is subtract, I need to write this a little smaller, is subtract 3x from both sides. Plus 6y equals 12. Subtract 3x from both sides. Which value did I tell you need to write first over here? You need to write your x value first. So now you have 6y equals negative 3x. Man, this one's going to be a fraction too. Oh well. Plus 12. Divide by 6. Divide by 6. Divide by 6. Y equals negative 1/2 x plus 2. So now, on your input-output values, what do you want your inputs to be? Multiples of what?
2.
Multiples of 2. Now, if this is a whole number, let's just say, once you rewrite it, let's just make it up. What if it was y equals 3x plus 2? Since it's a whole number, you don't have to worry about multiples of, whatever. Just use your standard domain, -2, -1, 0, 1, and 2. Does that make sense? The only time you have to really worry about or be strategic is when you're trying to get those fractions to cancel. Okay, if you understand that, that's everything you need to know for part 2 of lesson 8.2.